Good day, everyone. Today we are going to talk about access control models from ACLs to capability systems. This topic is very essential in cybersecurity because it focuses on who is allowed to access what is in a computer system and how the access is controlled. First of all, the world is a changing landscape. As technology has evolved from centralized mainframes to cloud systems, access control has become more challenging. Older systems were simpler because it's only one computer, one administrator, but now we have clouds, multiple microservices, millions of users, and shared resources. This leads to new security challenges like multi-tenant environments where many users share the same infrastructure. For example, let's say Netflix or Google Drive or something like that. A lot of systems that a lot of users use. So it's one system in a big cloud, but millions of people use that system. And one person cannot see the other person's data or information. So for you to even do this kind of thing, it requires a very advanced access control rather than ACL. And one of the components of this is discretionary access control, the DAC. The DAC is a user-controlled access. The owner of the resource decide who can access it. It is very common in personal computer, like Windows or Linux file system or something like that. And it has its own advantages and disadvantages. One of the advantages is users have freedom to share files easily, but it has a risk of if a malware infects your device, it gets all your permission. For example, a virus in your laptop can access all your files because it executes under your identity. So as I said, the risks are it's vulnerable to Trojan horses attacks, malware running as the user inherits in their permissions, and so on. And then we also have access control models, MAC. This is system centric rather than the other one that I said it's user controlled, but this one is system centric. In Mac, the system decides who can access what's using security labels like confidential secrets, top secrets, or so on. It's just like authority centralized. Uh, it's assigned labels to the users and objects and tell you which one you can use and which one you can't use. This approach is usually used in the military and government systems because it prevents users from changing permission and leaking sensitive information. For example, in the army, even if you have a file, you cannot share it if your clearance level does not allow it. You cannot share it if your clearance level does not allow it because it has different clearance levels, and if you don't have enough clearance level, you cannot access anything in that file. And then access control list, the ACL itself. The ACL are the most common model today. Each object, for example, a file has a list that shows who can read, write, or delete it. For example, a file called reports.stock might allow Alice to read and Bob to edit. This system is easy to understand and widely used in everything from file system to network firewalls. It's identity based. That means the decisions are usually rely on who you are, and it's found in most every file system and network firewalls. It's easy to audit by simple reading the list associated with the files. And ACL has its own strength and weaknesses. For its strengths, it's simple, it's easy to understand a thing. They are simple to audit, but they don't scale well in large systems. So, for example, in a company with 5,000 employees, removing one employee means searching all the files to find where their name appears. ACLs also suffer from confused deputy problems, where a privileged program can accidentally use its authority to perform dangerous action. And also, it has a support. It has mature tooling access to across all OS platforms. But the weakness, as I said, one of it is this scalability. Managing lists for thousands of users is error prone, and revocation removing a user requires scanning every ACL in the system. And confused deputy, as I said, vulnerable to privilege escalation exploits. Okay, so
So let's talk about role-based access control or RBAC. Before we gave permissions to every single user, that was hard work. But in RBAC, we put users into different groups like manager, like clerk, and it means that if you are in manager group, so you have manager permissions, or if you are in clerk group, you have clerk permissions that are completely different. So this model has some advantages and some disadvantages. The first advantage can be efficiency, so it reduces administrative overhead. And the second one is separation of duties that can enforce policies where critical tasks require multiple roles. So it means that it is good because it is faster for admin to manage it, but it can be disadvantaged like role explosion. So what does it mean? It means that if we make too many small groups for specific cases, the system gets messy again. Now, what about ABAC or attribute based access control? So, to solve that problem that we talked about, the role explosion, I mean, we have ABAC or attribute based control access. This model is smarter because it does not check who are you. It checks actually three things: subject, object, and environment. So, for subject, it is asking who is requesting or who is asking. Related to object, it's asking what is accessed or what file do they want. And for environment, the all things related to the context, like what is the time, sorry, what time is it, or where are they. So if I want to give you a full example about it, I can say that you can open this file only if you are in office between 9 a.m. and 5 p.m. So let's talk about a completely different thing named capability systems. Old systems or ACLs check the list of names or check the list of groups or names, but capability systems use tokens. So actually, it is token based. So just think of it like a car key. The car does not ask for your ID card. The car does not look as a list of names. Actually, if you have the key, the car starts. So this is called possession. Possession is authority. That says access is granted because you hold the key or token, not because of your identity. So the benefits can be fine-grained, so it means that precise control per object, or decentralized, that no central lookup bottleneck. So it means that it is very fast because the system does not need to check a central list. Let's talk about the core differences between these capability systems and old systems or ACLs. So, if we want to talk about it, we can say that the first feature can be about the fundamental philosophy that in ACLs it is identity based, but in capability systems they are token based. So, what does it mean? It means that access is granted based on the authenticated identity or subject, but in capability system they are token based, as I said. That is access. That access is granted based on the position of an unforgettable token or a specific token. What about direction of enforcement? In ACLs, they are object centric, but capability systems are subject centric. So, what does it mean? The object maintains a list of subjects permitted to access it, but in subject centric or in capability systems, the subject holds the unforgettable key or token that points to the subject. What about vulnerability or security? So, ACLs, as I talked about it, have confused deputy problem. So means that a bad user or a hacker can actually trick the program. But capability systems can solve it. The authority must be passed explicitly via the token. And about the scalability, so ACLs have low scalability, but capability systems have high. Why? What is the reason? So global lookup of permissions can become a bottleneck in massive or high concurrency environments, but in capability systems that can be high scalability, access checks are local and immediate. So, if you want to recap about the core differences, we can say that the most important part is security or vulnerability, because lists have a weakness called the confused deputy, as we talked. This means a bad user can trick a program, but capabilities are safe from this problem because you always need the specific token to act. Okay, uh, about this subject, that why we should use capabilities, because of two reasons, I think. Natural delegation or easy sharing, and confused deputy problem, as we talked earlier, or safety. So what does it mean, natural delegation or easy sharing? A program can pass a key to another program easily. It is like handling a key to a friend, so you don't need to call an admin. And about the safety or confused deputy, as I said, it fixes the confused deputy problem. A hacker cannot trick a problem into doing bad things because the problem can't act without the right key.
Sure, so I'm going to explain why capabilities. Natural delegation is simple as passing a variable a process can grant a, sub, a subset of its right to a child processes without administrative interventions, enable seamless less privilege architecture. Confused deputy uh, capability solves a confused deputy problem since authority is tied to the specific token passed without requires a malicious client cannot trick a privileged service into abusing its own intent authority. Implementation challenges. Despite their theoretically superiority, capability system faces practical hurdles. Number one, verification. Taking back a key is harder than removing a name from a list. It often requires indirect proxy objects. Developer minded, moving away from global namespace like file paths requires a paradigm shift in program. Number three, legacy compatibility. Integrating capabilities into existing ACL-centric OS design is a complex. Cloud hybrid models. The modern compromise cloud system um, often use a hybrid approaches. Number one, storage rights are defined centrally. Number three, runtimes a system a temporary invariable tokens like JWTs for actually access. Number three, zero trust in microservice. This protocol take in act as a capabilities violating access at every service boundary without center bottlenecks. hardware enforcement, Shiri architecture, uh, software capabilities can be slow to provide Shiri capability, hardware enhanced RISC introductions. Embeds capability projection directly into CPU. Number one, memory safety hardware boundary checking prevents buffers overflows. Number two, performance security enforcement at near native speed. Number three, future a foundation for secure uh, commercialized software. Conclusion: the future of access control lies in hybrid models that balance administrative um, clarity with a dynamic distributions environment. Thank you.